Okay, now that I got the circuit all designed, what I want to use now, I got all my paperwork on here now, and now it's time to build the actual circuit board for this now. Let's go on next. Time to play connect the dots. Wanting to waste all this here ink on the printed circuit board pen, I just use some red ink there and just covering as much as I can with some red paint. I'll show you what I'm doing here. I want all of my transistors to be easily changed out if they need to be, and so I'm modifying these here clips right here. I have one modified here. I'm just closing them in a little bit more so that I can slide them on like that, and have the availability to be able to take them off if I need to change the transistors anytime. Okay, I'm setting up where I want to put the collector at. kind of prototyping on my breadboards when I build a circuit. I'll build just one area at a time, and I'll work my way around. What I'll do is I'll build a certain part, and then I'll test it, make sure it's working properly, and then I'll just keep on adding to it. And I work in stages, and that way there I know that it's working to every stage that I'm working at. And it's the same thing when I'm doing a printed circuit board too. I don't just load all the components all at one time, but what I do is, again, I'll load certain components and then test the circuit to make sure it's working properly, make sure there's no any kind of solder bridges or anything like that, and everything's done properly, and then I'll just continue on a little bit at a time. So as of right now, what I'm going to do is I'm going to put all the resistors in here for the voltage divider. I'll hook up the main transistor here, but I'll leave the rest of the transistors out of the circuit. I'll put the sockets in, but I'll just leave the transistors out and then just build a little bit and then test it to make sure it's working properly, and then just keep on adding on from there. And it's made up from the breadboard that I was making, so they're ready to go now. That nice and smooth on the bottom. Okay, that takes care of that one. Just doing a quick double check here. 5K, or 1K, 1K, 100 ohms. Alright, that's good. Okay, I need to do a diode check here, make sure I've got the base where it needs to be. Okay, the base is on the bottom. Base is on the bottom. Yep. Okay, and here's the base. Okay. Goes like that. Base, emitter, collector, voltage divider, voltage divider. In the center here goes to the base. The emitter goes to the resistor, to the motor. It has the positive side of the battery, that's the negative. Let's take some continuity checks here, make sure everything's hooked up here. This should be the emitter, it should be up here. And the base should be the center here. That should be down here. Okay. Alright, and the collector here to the positive side of the battery, which is right here. Okay, transistor's hooked up properly. Everything's making good connection. So what I'll do now is put in the rest of the sockets for the transistors, and then we'll test it before I put the feedback transistors in. We'll just test it where it is right now and make sure it's working, and then we'll put the feedback transistors in and make sure the whole thing works properly all the way. Okay, this is for the opto isolator here. These are the transistor sockets I put in. All I used for those was I just used these here sockets like this, and I just cut them. Oh, they come in strips, and I just cut them to fit in. Here I'm using a regular socket here. I bent the tabs back. All I need is 6 of them for the opto isolator. Make sure there's no solder bridges. Okay, that's all of them. This right here is the 56 k ohm resistor that goes from the feedback transistor collector, and it's on the collector of it so as to bias the transistor, and also to keep any kind of leakage current from the ground coming out of the collector when there's no signal, keeping that leakage current to a minimum. That would go into the base of the PNP transistor that runs the opto isolator. That's the collector resistor right there. Resistor right there, 56K coming out of the collector here. What that does is, without that resistor, I could have a little bit of leakage current coming through here that would feed in during the time when the emitter is zero signal coming in. There could still be some current flowing this way here. By putting this resistor in here, it kind of like directs that current away from here. It pulls it this way instead, pulls it up. It's a pull-up resistor. Okay, this one here is a 470 ohm feedback resistor. This is from the feedback transistor that actually feeds the current into the PNP transistor, which in turn feeds signal to the opto isolator. Resistor right here, and that would be this resistor right here. That's what feeds back signal now to here, to there. This is the 4.7 k ohm resistor, and this goes to the collector on the PNP transistor, and that is current limiting, current limiting to run the LED and the diode in series for the opto isolator. It's nothing but a current limiting resistance. Now this wiring here, this is going to run the LED. This is going to come off the board here, and then it's going to go over to the lathe, on a panel on the lathe. So I have to have some long wire. So this wire is a real long wire. It's Christmas light wires, and there's one strand that goes through the whole string. That's not broken. It's one complete strand, and so I took half of that, and I'll use half for the one side of the LED or half the other side, and use that to for signal wire, because the current that's going to go through here is in the microamp region. I took a voltage reading across a 470 ohm resistor, and it's in a microamp region, so this is plenty of signal wire I can use for this. That'll go over here and over here now. Nice use of that Christmas light wire when the bulbs burn out, or when the wire's no good anymore. I better make sure this wire is good. I'm going to take a continuity check here real quick here and make sure that this is not any kind of broken wire. That's why it wasn't working in the first place. Okay, it's good. Had bulb connection. After a while, those sockets on the Christmas wires, Christmas lights, the sockets eventually go bad, and that's probably what it was. Probably bad sockets, because this here wire is good. Their wire that will go to the other side of the LED. I think this side is the this is the anode side. I think I have to look and see. All right. One more set of Christmas light wires, and this will be for the potentiometer up here, which will give the sensitivity of adjusting for the torque control. The other side of it, which goes to the positive side of the supply, and that takes care of the 200 ohm potentiometer. It's actually a trimmer that's used for sensitivity of adjusting the sensitivity for the torque control feedback. Some preliminary tests now. See how well it's soldered up, because I know the prototype worked properly. When I built it on the breadboard, it worked perfectly. So if it's going to work perfectly now, it's going to work. If it doesn't work nice, then it's because it's either a bad soldering, or else there's a bad layout on the tracks and things for the printed circuit board. But other than that, the circuit itself proved out to work properly. So we'll have to see how everything worked out now as far as laying it out to put on the board here. Just for the one transistor only, and we're just going to check and see if the voltage on the output of the motor is about 10 to 12 volts less than the voltage coming out of the supply. This will be the voltage coming out of the supply right here, and this is the voltage across the motor, and this has to be about 10 volts lower. I have it set on the 40 volt range. The supply voltage shows about 39 volts, and we're about 31 volts there, so we're good there on that setting. That means that the transistor is working properly there. Now we'll set it to the 60 volt range, and that's showing around 60 volts, about 48 volts there. It's about 10 to 12 volts difference. That's what we're looking for. And one last one now, and now we'll change it to the 80 volt range. Supply voltage 80 volts, 65 volts there. Okay, so that's what I want. I want this here voltage across the motor to be about 10 volts, at least 10 volts lower than the supply voltage. That way there it has room, headroom to be able, ceiling room to be able to rise whenever I put a load in the motor and the torque control is working. This has room now to work within that range there. That's why this has to be about 10 volts lower in order to be able to work, because this drops in voltage whenever I put a load in the motor. The actual supply voltage drops, so this has to be able to pick up for that drop and rise up a little bit. Okay, so everything's working fine. Everything's working good on the transistor. So that's the one transistor there working right now. So the next what I'll do now is I'll start putting in the rest of the components and check for torque control now to see if we're getting kind of feedback and things, and that'll be next. But right now this was just a good preliminary check to make sure that the transistor is hooked up right. Next test is now I want to make sure that this here is tracking down here again like we did the other time. So what I'm going to do is I'm going to make sure now that whatever the voltage is across the motor, I want the same voltage to be at this side of the around this, or close to the same voltage on this here center here of the transistor here that's going to be put in here later on. And I'll be using that 3 voltmeter there. This will be the second test now to check for tracking. Okay, so now I have 32 volts across the motor while it's running. I'll check the base here. I should have close to 32. Okay, I got 32 on that range. 31.9, 31.9. So it's tracking the motor there on that range. Put in the next range here now. Okay, the voltage across the motor around 49 volts at the base. Okay, around 49 volts, good. And now we'll check the last range here. Motor 66 volts, the base. The next transistor 66 volts. Okay, so that's tracking properly now. The 2 preliminary checks worked out good. I have just this transistor here in. I'm running the motor through here and checking here. And the motor voltage, the voltage at the base of the transistor is tracking the motor voltage properly. And on this side here, at the base of this transistor here, which this transistor is not in here yet, but I'm just checking to make sure this is tracking properly here with the increase in voltages. And so everything's tracking properly here. So next would be now to put in the transistors in here now, and the optical isolator, and make sure that the whole feedback circuit's working properly now. But right now it's proven out again, like the last video I made with when I was on the proto board, that the motor voltage and this transistor here is tracking with the change in voltage to the circuit. At the same time, it's also tracking on this side of the voltage divider also, which goes into this transistor. So the voltage dividers are tracking, the transistor is tracking with the motor with different values of voltage coming in. So that part is working properly on the circuit board. So it means everything is wired properly, everything's laid out properly, and everything is soldered properly, and everything's working properly now. So next now will be to put this here rest of the circuitry in there and check that to see how that's working now.